Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Syaiful Masubi. Today I want to present about numerical analysis based on our task. Okay, firstly I want to introduce our group member. First is Muhammad Hafiz bin Muhammad Rozi. Second is Muhammad Haji bin Hadi. Third is Devayantis, and fourth is Fakullah bin Ahmad Samiri. Okay, next I will introduce a little about numerical solution of integral. So, firstly, why we use a numerical integral? So the reason that we use numerical integral compared to the normal integral because it is a tool that used by engineers and scientists to obtain approximate answer for definite integral that can be solved analytically. Okay, for example, in statistical thermodynamics, the model for calculate heat capacity of the solid involved function that shown in the slide. So this function cannot be solved using normal integration. So uh, we use numerical analysis to solve this problem. Okay, next is as we know, there are three type method of numerical integral that we use in this task. There is first is trapezoidal rule, second is Simpson rule, and third is Boole's rules. Okay, this is the graph of trapezoidal rule. So, uh, as you can see here, the shaded region is the area under graph that we will measure. So, here is the unshaded region that we call area in our calculation. So, the less the error, uh, the close the value of the value to the actual reading. Same as Simpson rule and Boole's rule. So the Simpson rule, the shaded region is the value that we have measured, and the unshaded is the error that occurred during our calculation. So next, I will pass to Muhammad Hafiz to present about uh, calculation based on our task.
Of estimating the surface area of a pond by using trapezoidal, Simpson's and Boole's rules. Okay, so from the question we know that the measurements are taken across every 20 feet along the width. So here we know that the h is 20, and from the table we know the sub-interval is 8. Okay, moving on to the calculation first, the trapezoidal rule. So from the question earlier, we know the h is 20, and the 8 is subtable is 8. So we just put it into the formula for the trapezoidal, that is h divided by 2 with a function 0 and functions 1, and move on to the next function until, so we put in the value of h and 2, and the number of sub-interval here is counted from the table, so we get the value of area is 9,920 feet square. So moving on for the Simpson rule, it's just the same. We simply use the Simpson composite rule. So since it's a composite, we didn't use 2f, but we start off with 4, 2, 4, and f again. So that's here is how it should be for the Simpson rule. So since we know it's composite, we just enter the value of h over here, and we will get the value of area that is 10,413.33 feet square. Okay, moving on to the Boole rule. Boole rule is just the same, but we have to multiply it for the h with 2 and divide it with 45. So we start off with 7, 32, 12, 32 plus 7. That's how it should be for the Boole's rule. So here how it should be calculated. We enter the value of 20. This is the value from the table, and we got the area is 10,357.33 feet square. Okay, that's all for the calculations. Simpson is 10,413.33 feet square. So we just need to multiply it with the depth to obtain the volume. So the depth is the 10 feet. We got 104,133,000 cubic volume. That's the volume. So we just need to divide one fish for every 1,000 cubics we times with the volume of the pond. So we will now know that is 104.33. That's the correction. So basically we know that 104 fishes are needed to fill the pond. So that's the amount of fish that was needed. Yes.
Okay, as a conclusion, from the calculation that we have done before, we know that the Simpson rules are more accurate compared to the trapezoidal and Boole's rules because it is it uses parabolic approach to estimate the integral of the data. So Simpson rules are most accurate compared than others. That's all for our group. Thank you. Okay, here let me show a little about simulation that we use MATLAB. We try to measure the area under the graph using MATLAB. So here what we can see, x is equal to 1, 1 and 9. So it means what we can see here, it means it start from 1, and the second number is for the plus of the next number. So here we can see from 1 into 2 into 3 and other, and so on until 9. So the 9 here is represent the last mean of the number. Okay, R here is represent the number of width, as you can see here, 0, 50 until 0. So H here represent the stat of the pond. So here we can see 20 feet. Okay, next is N. N is equal to 9. N is represent the number of the means. So here we have 9 numbers. Okay, next we go for the next variable. This is ST4. The ST4 is represent the formula that we use here is in the formula we have 4 and 2. So ST4 is represent for 4 at the F1 right here. So ST2 is represent the formula right here for the 2F2. So as we can see here, these two program is used to as a formula that we use to measure the area under the graph in the Simpson rules. So what happen if you run this program? This graph will display when we run this program. The shaded region show the area that Simpson rule are calculated. So here the unshaded region is the error that happened in the calculation. So as a conclusion, trapezoidal rule is an average of the area of triangle formed by line between the 2 points. It's also known as the sum of the Riemann sum. Trapezoidal rule is more accurate when the number of the interval is odd. However, the case even interval in the case of even interval, Simpson is more accurate as it uses parabolic approach to estimate the integral of the set of data. So what we can conclude here is the Simpson is more accurate compared to the Boole's and trapezoidal. So thank you.